Hi everyone, my name is Dimitri. I'm IAB Europe's Data Analyst and Sustainability Lead, and today I'll be talking to you about applying the Global Media Sustainability Framework on digital channels. Before we dive in, let's remind ourselves why exactly we need a framework in the first place. There's been interest in biasing media investment based on environmental sustainability metrics for quite some time. That means moving media spend towards more sustainable sources and working with more sustainable intermediaries. To do that, we need organizations to trust the figures offered and used by agencies, vendors, ad tech, and publishers. And for that, we need consistent and equivalent estimation of environmental efficiency. That is the main reason why the industry has asked for a common modeling foundation so the ecosystem can then also shift focus to achieving footprint reductions, which is the ultimate goal once we have a consistent way to quantify these. Looking at the framework we've supported over the past year, we have 5 different stages: creative production, selection, delivery, consumption, and corporate overhead. Going from the storage of produced assets to ad allocation, to transmitting the ad experience itself, to the energy consumption in the consumer device, and then finally including non-media emissions from across the value chain. You'll notice that targeting is highlighted. That is because we currently don't have a model to really understand the emissions of collecting, storing, and activating user data. And you'll also notice that enterprise emissions are highlighted exactly because we need further guidance to really narrow this down and shape the corporate overhead stage. In terms of emission sources, we have 3 main ones: data centers that handle things like storage, bid processing, and logic. And here we also account for the overhead required to do things like cool down the data center. Networking infrastructure, in particular, we're looking at the emissions arising from things like transferring RTB requests and responses, as well as the ads themselves. And we're trying to include CDNs because they shorten network routes. And then again, the consumer device for networking and display. So what's next for industry level working groups? What kind of questions do we have to tackle now with respect to application? Let's look at 5 topics from the 5 different stages of the framework. Beginning in creative production, there are questions around the attribution of produced assets. So what happens in scenarios like when you use these assets today in a campaign and then you end up reusing them sometime in the future? We also need to maintain equivalence of estimation with purchased assets or stock assets that often don't really come with any figures describing the environmental efficiency of their production. Under selection, let's look at these 3 questions with respect to programmatic trading paths. Now, this is what the simple linear representation of programmatic paths looks like under the Global Media Sustainability Framework. It doesn't necessarily represent the more complex reality of programmatic, but it works well as a baseline model. Optimally, the framework should cater to both types of application, so both simple models and the more complex work done by vendors who essentially leverage the data available to them through commercial relationships to really map out the programmatic paths of, say, a publisher, and also figure out the exact characteristics of those paths. So which SSPs are involved, which DSPs are involved, how efficient are these organizations? It's also important to keep in mind a couple other questions. A, should we really be treating reseller and direct paths the same way? And B, how do we represent all of the activity involved in the auction? So when you have an auction and you're looking to account for the carbon footprint, you're not just looking at the winning bid. Winning bid might look like this, might be very direct, very energy efficient. At the same time, other bids might look like this, more indirect, more energy inefficient. But because we're taking all of this activity into account, a question arises around how we represent both the efficiency of media owners and media buyers. To explain this, let's look at a simple, non-digital example of a car auction in Southeast England. Say there are 3 cars available, one that was driven from Northampton, one that was driven from Italy, one that was shipped from the US. Immediately, you can understand there's probably a different level of carbon emissions associated with making each of these available. At the same time, we have 3 bidders, one that took a train from London, one that took a commercial flight from Germany, one that took a private jet from Lagos. If bidder 1 wins the Countach in the middle and they want to understand the carbon footprint of this transaction, they might begin by asking the owner of the car questions. For example, how it was made available, perhaps even questions about the car itself, manufacturing emissions, gas consumption. But that's not the whole story, right? you'd also need to send out an RFI to the other bidders, for example, to try to understand how they were able to access the auction itself. This is quite analogous to programmatic, where for a full understanding of the emissions associated with a transaction, you would need to issue questions towards various stakeholders about how exactly they are participating. Part of that is representing the geographic distribution of data centers, and this is particularly challenging in cases when we have data availability issues. So selling an impression might look like this if you have an end-to-end platform with data centers in France, for example, but programmatic can also look like this, with a variety of data centers activated and participating in programmatic across the continent. Now, the way that this has been done in the past is by using a variable that essentially represents an assumption, the assumption of what ratio of data centers sit abroad. If this is set to 0, we're going to be taking the country average for the grid intensity. If it's set to 100%, the European average in this example. If it's 50%, the midpoint between the two. Now, certainly a very interesting question here, but another interesting question that hasn't been discussed yet is what European average we're actually using. Because this can go from a simple average to one that is weighted by the energy demand in each market. We could use aggregated data to try to understand where programmatic infrastructure tends to sit in Europe, and we could even localize this. So looking at the Swiss market, let's say, where do the data centers that participate in programmatic in that particular market tend to sit across Europe? In terms of delivery and data transfer in particular, many interesting questions here about how exactly you figure out what level of emissions you're responsible for participating in the internet. But let's look at a more simple distinction here between the power model and the conventional model. Again, beginning with a non-digital example, that of a water grid. Let's say we have a well and a water pump. What's really important to understand here is that for water to be available at the tap every time you request it in one of these households, some of this infrastructure has to run continuously. And that means there's an energy overhead. Now, there are two basic reasons for that. A, it would be quite energy inefficient to turn these off and on again. Same way it would be energy inefficient to turn on the modem on your phone off and on again. And secondly, you can't really tolerate latency in this system. So when you turn on the tap, you want water available then, not 3 minutes later because some pump 10 kilometers down the pipe is just turning on. And the first part of this quote alludes to the fact that the internet is quite similar. It's designed to be operational 24/7 and resilient to failure. The second part of this quote is also very interesting because it alludes to the fact that all of this work is necessarily going to be based on modeling. Because of all the different routing algorithms to try to find the most efficient ways to move around traffic, it's really hard to get any kind of deterministic understanding of what's happening and what the emissions will be at some point in the future, exactly because it all starts to resemble chaos because of the complexity. Now, looking at the previous study and this graph here that's actually based on data from the study at the bottom now, you see the difference between the power and the conventional model. So traditionally, the idea was let's figure out a way to assign a carbon footprint to a certain payload that's being transferred. And it was a quite proportional model. Now, what's different about the new model is that now it's far less sensitive to the payload itself, and actually the bulk of the emissions comes from that overhead that I mentioned earlier. And here we have some scope 3 data that actually shows the difference in terms of applying this to a digital advertising use case. So for a 15-second video, that's 2.25 megabytes in this case, the conventional model yields a result of 173 grams of CO2 equivalent, the power model only 7. Because that's a 25-fold difference, you can begin to understand that the insights offered by this research can actually be quite impactful in terms of applications of the global media sustainability framework, and it's really worth it to explore this question further, especially since all of these differences scale with the campaign size, for example. Then let's look at consumer device power. So how do we model the energy required to perform different tasks, like download data or render an ad experience? These are the main two that are included in the framework at the moment. Furthermore, there's a very interesting question around client versus server-side computing, which arises because client and server-side computing have a significant difference in terms of energy efficiency. So how do you compare, for example, a header bidding setup that consumes resources on the browser versus a header bidding setup that consumes server-side resources, at the point at which this can actually have a tangible impact on the total emissions you get from a model based on the Global Media Sustainability Framework. This is also worth exploring. Finally, looking at corporate overhead, there's a question about what enterprises are included here, especially looking at programmatic transparency difficulties, where you might not even be able to understand what the value chain really looks like. Furthermore, looking at the second part of that question, what kind of emissions are we including? The idea here is to include non-media emissions. So things like business travel and office space. But to do that, again, we need to ensure that these are comparable and equivalent to avoid things like reductions on paper. So when you switch business partners because you think one will be more sustainable than the other, but in fact you realize there's no actual difference in terms of the energy efficiency, let's say, it's actually a difference arising from the calculations and the modeling and the assumptions and the data sources. That's something we want to avoid because we want to keep all of this optimization focused on achieving real tangible reductions in carbon emissions. That's the wrap. If you find these questions interesting, feel free to reach out and join the IAB Europe Framework and Methodology Working Group. We're going to be continuing our work in support of the Global Media Sustainability Framework, working very closely with Net Zero in the coming months. And we have a great network of specialists from across the ecosystem that are very excited to be continuing on this journey. Thank you.